The FFS2000 is a fusion splicing workstation which is capable of performing all steps of the splicing process: strip, cleave, clean, splice, recoat and proof test. These steps are integrated into a single semi-automated system that produces consistent splices quickly and efficiently. Left and right fibre holding blocks are used to secure the fibres during the preparation, splice and recoat stages. The fibre holding blocks are used in conjunction with a transfer jig that precisely positions the fibres, thereby assuring the consistency and strength of the splice. Rotary fibre holding blocks are available for processing polarisation maintaining and microstructured fibres. Standard non-rotary fibre holding blocks are used with single mode and other fibres. Rotary fibre holding blocks have a rotary mechanism. This means that PM and structured fibres can be rotationally aligned. The fibre holding block has a U-shaped frame and a centre spring-loaded block. The fibre cleave lever and the spring are used to tension the fibre during cleaving. The fibre holding blocks are fitted with V-groove inserts. These, together with the magnets in the lid, secure the fibre in place as the fibre holding block is moved around the workstation. V-grooves of a variety of different sizes are available to accommodate different coating diameters. The coating is stripped from the fibre using a pair of thermomechanical strip inserts. The bottom insert contains a heating element used to soften the acrylate coating. The inserts also contain a matched set of stripping blades at each end, which are used to remove the softened coating. Strip inserts come in a variety of sizes to accommodate different combinations of coating and cladding diameters. When the fibre holding block is at the stripping position on the workstation, the coating is captured by the strip inserts. Heat is applied which softens the coating. As the fibre holding block is slid backwards in the stripping slot, the softened coating is removed by the blades. The soaking and cleaning stations have an ultrasonic bath that can be filled with a solvent. The fibre is immersed in the solvent using the dunking jig. An indicator lamp lights up when the required time for cleaning or soaking has been reached. A tension and scribe cleaving method is used to cleave the fibres. During cleaving, the fibre is held in place at the cleave block using a lower and an upper cleave insert. A variety of cleave inserts are available. When the cleave process is initiated, a diamond cleave blade moves close to but does not touch the fibre. The blade then slowly moves forwards using a pecking motion until it touches and cleaves the fibre. The splice station has a splice head that contains the filament and objective lens for the imaging. On workstations designed to align structured and polarisation maintaining fibres, there is also a mirror toggle that switches the mirror locations in the splice cap. These mirrors provide both side and end views of the fibres. The splice station also has fibre positioners and graphite V-grooves to support the fibres and position them in the XY direction. Graphite V-grooves of various sizes are available. The spliced fibre can be moved using the transfer jig to the recoat station. The recoat mould consists of two precision ground quartz glass plates. A channel in the upper and lower plates forms a mould cavity of the required recoat diameter. With the fibre loaded into the recoat station, recoat material enters the mould through the injection port. UV lamps underneath the mould are then used to cure the UV acrylate recoat material and form the recoat around the splice. Some FFS2000 units are fitted with a proof test station. The proof tester consists of two mandrels onto which the fibre is wound. Pressing the release button on the top moves the clamp forwards, enabling the fibre to be clamped to the mandrel. Then, maintaining tension, the fibre can be wound round the mandrel. The unit is provided with a clear plastic proof test shield which should be used to contain the glass fragments should the fibre break. During a proof test, the left mandrel remains stationary, but the right mandrel rotates and applies tension to the fibre. A strain gauge connected to the proof tester monitors the force applied and reports this to the FFS3 software that is used to control the unit.